Let me say thanks a lot to Freescale for this kind of invitation to the European team. This is just to say that we have a great cooperation in place since 1991. We have done great things all together. We have made 2 generations of common rail system together. We have made the Multiair, the twin clutch transmission recently, and we also have great products in the pipe that will support our development for the next generation of powertrain system in 2014, 2015. So we are really proud about this tight cooperation with you. So today I will follow a kind of top-down approach, starting from the top, setting the scenario for the entire vehicle, just a few ideas about the vehicle as it is, driver and trends in the powertrain technology, the way in which we are approaching the vehicle electrification, and how those trends and drivers are driving the so-called concurrent challenges we are facing in the automotive electronics, and what this implies in terms of silicon suppliers, if you like, in terms of requirement and things like that, and then some conclusion. Okay, so just a few words about us. I'm working with Fiat Powertrain technology that was born in 2005 after the dissolution of the joint operation with General Motors. At that time, we had an operation called Fiat General Motors Powertrain, devoted to mainly powertrain activities. So after this experience, with GM, we decided to collect all the resources, activities, know-how related to powertrain activities into a single company, which is called FPT, which is trying to stay on the leading edge in terms of technologies, to transfer this into a wide range of products, to make synergies across all our processes, and to develop also non-captive markets. So we are basically selling our technology even to other car makers. We are about 22,000 people worldwide with a real global footprint. 10% of those resources are devoted to R&D and advanced engineering. So just a quick look about the evolution of the vehicle, if you like. We can start saying that the vehicle is the result of a kind of evolutive process that started more than 1 century ago. And now we can basically assume that it is a kind of mature product. We still consider that the vehicle is the solution to the individual mobility over the years. And we have also to recognize that the final product is the result of a very, if you see, this is a kind of B-segment car developed by Fiat. This is the result of a very accurate assembly process of more than 15,000 parts, and the cost is still attractive because we are in the range between 12 and 30 euro per kilogram. So this is the cost of the, if you like, of the Parma ham, and we can also consider that this, at the end, this is a very sophisticated technology, especially in the upper segment. The vehicle is becoming a very complex part, but it has to be sold at a very attractive cost, and this is one of the reasons why there is such a big pressure on your shoulder in order to provide a cost-aggressive solution in the automotive. There is also, let's say, a clear request in terms of sustainable environmental mobility, and this will force a kind of discontinuity with respect to the past in terms of car segmentation. At least in Europe, we will see that we will most likely divide the mobility into 2 different segments, the so-called urban mobility and the extra-urban mobility. Look at those figures. For instance, in Europe, the average age of the car fleet is more than 8 years. In 2008, we had something like 220 million of cars running in Europe. The average car density for 100,000 inhabitants was In 2009, 470 cars, and in Italy it was above 600 cars per 1,000 inhabitants. This is the same car densities as in Los Angeles, but with the main difference that Los Angeles was conceived for the cars, while in Europe the same density has become really critical for the urban mobility. So the consequence is that we will, the next challenge will be the identification of solution able to cope with our right for the individual mobility and with the urban compatibility, at least in Europe. We can also say that the drivers to technological innovation in the past were mainly driven by cost reduction in order to allow a wide usage of the car. But then they have moved towards performances increase, comfort and ergonomic improvement, safety improvement, fuel economy, and emission reduction. The last three items are still today the top priority for us, and will be the drivers for future technological evolution in the perspective of sustainable individual mobility. The main difference is that until the 90s, the car innovation was dominated by mechanics. During the last 20 years, the innovation has been mainly driven by electronics. And this is continuously growing, so the contents of hardware and software is becoming every day much more important in the innovation of our vehicles. So, talking about powertrain. At Fiat Powertrain Technology, we decided to work on three main topics. The diesel. We released into the market two generations of common rail system. This is the last one, the so-called the Multijet 2, which is based on a brand new concept for the servo valve, which has equal or higher performances with respect to piezo, but at much lower cost. We have been able to realize the so-called digital injection rate shaping. I will talk about this later on, talking about processing capabilities. Basically, we have been able to reduce CO2 and NOx emission, together with, in general, a better combustion process, so lower noise and better drivability. In the field of gasoline, we just released some months ago the Multiair technology. We have been working on this technology since 15 years. You will see the engine head in the technology lab. The Multiair technology is a kind of breakthrough electronic valve control system, which is basically controlling the air mass stroke by stroke, thus matching the dynamic behavior of the air with respect to the fuel. I will talk about this later on. The main benefits are, and it is a throttless system, so we are avoiding the pumping losses typical of the gasoline engine. So we have been able to increase the maximum power of the engine, the low RPM torque, so this means fun to drive, basically. And we have also been able to reduce the fuel consumption and CO2 emission. Last but not least, we decided to address the transmission area, and we opted for the tri-dual clutch transmission. This is not brand new. Volkswagen is in production since many years. We believe that this is really a good technology, and we have developed a family of transmission. This is the first one which is going into the market, which has better performances with respect to automatic transmission in terms of, let's say, driving feeling, and we can get even, let's say, lower fuel consumption with this. All those technology has been transferred to Chrysler, and we are working a lot with them in order to release, even in the US, this technology with Chrysler as well. So this is what we have done over the last years, what we are doing for the next step. First of all, we are, the Multiair technology is a very flexible technology. So we are, let's say, adopting the Multiair technology even on diesel. We have demonstrated to ourselves that the combination of the most sophisticated combustion process control of the diesel together with Multiair will achieve the Euro 6 limits in Europe at a reasonable cost. And since it is a flexible technology, we can apply this on passenger cars, on light-duty engines and even on heavy-duty engines. So it is a very flexible technology. Concerning Multiair, this is just the beginning. You see in the lab a video which is showing the behavior of the Multiair. This is the second generation of the Multiair with a multiple command within the same law. This is providing a much better control of the combustion process, and this is a perfect match with any kind of direct injection. It could be either gasoline or diesel. We will have a perfect match in terms of dynamic behavior, stroke by stroke, of the combustion process. So, talking about the vehicle electrification, I like to start with this picture, which is a picture of more than 1 century ago. That was a discussion between Thomas Edison and Henry Ford. They were discussing about the technological transfer between, let's say, the electrical machine and the thermal engine for the auto vehicle. And Edison was saying to Ford that the storage battery is too heavy, etc., etc., etc. So this is also our concern. We are very cautious on that. This is still a big point. The storage battery technology is still suffering for a lower energy density with respect, if we are talking about the entire system, with respect to fuel and gasoline, of about 2 orders of magnitude. And they have made a fantastic progress over the last year, but there is still a consistent gap in terms of energy density. There is a big problem in terms of reliability and lifetime of the batteries. There is another problem which is related to the entire amount of CO2 which is released into the environment if you are taking into account the entire life cycle. This means producing the battery, recycling the battery when they are fully exhausted, and the CO2 which is produced by electricity for the plug-in vehicle. So if you are taking into account all those numbers together, according to our estimation and some analysts in Europe, this means that you will break even after 3 years, more or less, with a pure electrical vehicle. So we are really cautious on that. And last but not least, there is the big problem of infrastructure. So we need infrastructure for the plug-in vehicle. Nevertheless, that was announced on the last Fiat Innovation Day in Europe, directly by our CEO, by Sergio. This is, let's say, our proposal for the hybridization of the powertrain system. This is a jewel. This is the last small gasoline engine. It's a 2-cylinder engine, Multiair turbo, 110 horsepower, which is matched with a brand new dual clutch system, 100 Newton meter. And you can see the dual clutch has 2 inputs. One is the thermal engine, the other one is the electrical machine, and 1 output on the wheel. So it is a very simple solution for having a parallel hybrid. Again, this is not a brand new solution. It is very well known in let's say, in the literature. Simply, we have implemented that in a very compact, low-cost approach. And most of all, it is a kind of add-on option to the baseline powertrain, which is simply minimizing the specific investment. Take a look at this. This, for instance, is the inner part of the transmission with the most sophisticated leverism for the gear shifting, etc. This is very expensive. And this is a cross-section of the actuator. This is for a generic tri-dual clutch system for small city cars. If you see this one, this is the cross-section of the electrical powertrain we are proposing, which is basically remaining the same apart from the mechanical housing, which is changing, but all the rest, the inner part, which are the most expensive, remains really the same. We are simply adding the machine on the even shaft, and we are also controlling the AC compressor for climate control inside the vehicle, which is driven by the electrical machine. So it is a very, very simple system, very compact. And as I said before, we are simply sharing the investment over a large volumes for classical city cars. And this is the result. This is the top view of the under the hood compartment of the Fiat 500. This is the electrical power management unit you can see in the technological lab that was fully developed by us. By the way, there are two Freescale processors on that. One is controlling the electrical machine, the other one is controlling the plug-in, the DC-DC converter, whatever you like. Those are the batteries which are located in the rear, in the place of the spare wheel, so we are not losing any capacity in the trunk. The battery are cooled by air with a dedicated system which is not influencing, which is not affecting at all the internal climate system of the vehicle, so we are not wasting energy on that. This is the final implementation, the cars running in Italy. This is the Fiat 500 with the plug-in option. This is the under the hood compartment, and if you see, this is the entire system which is pretty compact. The powertrain here, the power electronics, and the batteries in the rear with the plug-in option. So if you are trying to translate all those, let's say, ideas into requirements for the automotive electronics. Again, this is a summary, then I will go into more details later on. First of all, I would say there is a great request in order to improve, in a generic way, quality of the automotive electronics, quality, reliability, the fact that we are moving towards zero defects is a must. You will see later on why. There are emerging standards which are going to be accepted by us. AUTOSAR for a better software coding, the ISO 262 for safety. You have been able, as a silicon supplier, you have been able to scale down the technology in order to get better performances while reducing the cost. And there is a clear request in order to increase processing performances and the memory on board, the embedded memory on board for the microcontrollers. You will see later on why. But at a glance, this is, for instance, a good reason. If you are taking into account the engine control, the inner control loop more or less is running at 5 milliseconds, and then 5, 7, 10, 20, 50 milliseconds. The transmission control is much more demanding. 1 millisecond, 2 milliseconds. The hybrid has opened a new domain because, for instance, we have moved all the controls into the digital domain in order to be more flexible, etc., etc. This means that we have to upload the new values in order to control the electrical machine, to control the energy flow, at least every 100 microseconds. In some cases, for the cars we developed for Ferrari, it was running at 50 microseconds. So this means that we have to optimize the code for the control of those parts, and the processor should follow those requirements. This is a very important point concerning, in general, let's say, the reliability of automotive components. That was a nasty experience, a painful experience we had together with GM some years ago, because we had a common engines, a 5-cylinder common rail engine, and we had a lot of problem in the mechatronic system which was controlling the swerve. And this is even worse, if you like, because this is the sensor which is mounted on top of the on one side of the rail. This is sold in more than 10 million parts. So this has been sold in more than 10 million parts so far. All those components, even though they were fully compliant with the ASIC 100, failed in the field because they were marginal with respect to some specific application. So what we are simply saying here is that we have to go beyond the ASIC 100. The ASIC 100 is just a go-no-go. And we do not have any indication where we are marginal, if we are close to the limit of the components with respect to the specific application. So we have to improve the robustness of the electronic components, and we have also to reduce the qualification effort, because the qualification process is very long now. This is conflicting to the fact that we have to be faster than in the past to release our product into the market. In Europe, we have developed across Europe a methodology which is called robustness validation, which is exactly addressing those points, which is giving us a better perspective of the behavior of the system and the components. You know this better than me, much better than me. Zero defects. This is becoming a must, because if you are taking into account that in every car we have from 10 up to 80 control system in the upper class, with an average of 300 components, active, passive, so then you can easily, this is then multiplied for several 100,000 vehicles per year, so you can easily understand that the PPM concept does not work with that. And this is the reason why, together with most of the silicon suppliers, we are working in the field of zero defects. The idea, for instance, of introducing the safe launch process is a good idea in order to smooth the ramping up, let's say, the production, but this is clearly a must for us. Concerning hybrid, this is a nice, this is a very important point. The power electronics which is used in the hybrids is at the moment derived from industrial application. We are simply saying that this kind of technological transfer could be extremely complex, perhaps painful, and it is far from being acceptable because, for instance, at the moment, as far as I know, we do not have a qualification process which is agreed worldwide, for instance, for the large power devices. The environment is really harsh. The lifetime is a problem, and at the moment, we are really far, especially for the plug-in system. The plug-in system requires the fact that the electronics is working even when the car is idling. So we are looking for numbers which are bigger than the usual one. So lifetime reliability is still an issue, and you see here some silicon maker is trying to make a bridge between the industrial domain and the automotive domain. But we have to be clever in order to reduce the effort, in order to go and to achieve a practical solution for the automotive. And for instance, we are trying even to use new materials which are, let's say, less expensive for the automotive, but giving the same reliability figures. Okay, there are many sessions about ISO 26262. And simply, again, underline the fact that this is becoming a reality. This will be affecting the entire development process, the way in which we are going to develop software, and the way in which we are designing the hardware, even the microcontroller. This is going to be a reality. Talking about performances, you know, again, some of you know better than me this picture. Since the 90s, with the 6836 family up to now, with the eSYS platform, we have seen a very impressive increase in terms of processing performances. And we also believe that there is a rationale for moving towards the multi-core processor for several reasons, because we will have more MIPS per watt, we will have more MIPS per square millimeter, so even a very attractive cost, giving higher performances. We should be able to keep under control EMC issues. We could better balance the task management among the different processing units. And it is perhaps the proper way to address safety-relevant automotive applications.